Hi there. This is a really strange way to start my makeup portfolio video, but I think it's the best way for me to do it. This right here is my shed, and this is where it all started. So, let's take a look inside. So, this video is going to be about the drones that I've been working on for the last few years, and this shed has sort of become my makeshift lab or workshop, simply because my parents have had enough of wires being stricken everywhere around the kitchen, so fair enough. Where do I start? Okay, well, let's start right over there. You've probably seen a few of these if you've been into robotics over the last few years. This is a DJI flame wheel chassis, or, well, what I have here is a rip-off of one. I might sound a bit dismissive of this, but no, this was my everything at one point. Around 3 years ago, this was my first drone frame. I bought it with a job lot of random parts off eBay, and some of the original ESCs are still on there. And this was my first drone, I'd say. At least my first DIY drone. Before then I had, those toy drones that kids have. Yeah, so this thing originally came with a KK2 flight controller, which, I'll be honest, is not very good. It just about performs a PID loop to keep it stable. It's from around 2011. But yeah, that's when my journey started. When I first built this drone, I was actually really impressed. I thought, this is amazing. I've constructed what's equivalent to that toy drone technologically, but from scratch. But I basically wanted more. I kept going, and as you can tell from this video and probably the intro, I did keep going. So, let's see. What around here? Aha. Sorry for literally how made up on the spot this is. This was the frame from my second drone ever, christened the Zephyr 2. As you may have noticed, this is entirely carbon fiber, and there's not a titanium, yes. As you can imagine, this is constructed for as little weight as possible. It looks a bit dodgy right now, that's because it's designed to be foldable, these arms pivot, but yeah. Why is it carbon fiber? Well, to be lightweight, as you probably guessed. Why is it lightweight? Well, this is where another chapter of my sort of drone endeavor started. I wanted to improve the flight time of drones. I started off with this flame wheel chassis over here, and I thought, if I want more flight time, why don't I add more batteries? This was me a few years ago, by the way, so excuse the logic. Naturally, the drone did not improve in flight time. In fact, it reduced. There's many reasons as to why, flight time is what it is. You have all sorts of factors being balanced. How hard your motors are working, how much current they spend, the battery on board, energy density, weight, etc. So my first step was improving the weight of the drone. In this case, carbon fiber construction, alongside just some pretty decent off-the-shelf motors. And I used some good battery packs, as opposed to using LiPos, as most drones do, which have an energy density of around 150 watt-hours per kilogram. I used some lithium ions, which I took from some old power banks, so that was around 200 watt-hours per kilogram. And I got a decent flight time out of this drone. I'd say around 1 hour of hover, which was amazing, considering, I don't know, when I say a drone, what probably comes to mind is a DJI product, and those things get around 30 minutes of flight time. So, well, that journey did not end here. This shed is filled with a bunch of wires for a reason. This was drone iteration 3. As you can see here, it's much larger than that one over there, and much more solid. That's because I'd had enough of that drone sort of coming apart, being flimsy and bendy. Oh, I've got a splinter from a carbon fiber shard. Give me a second. Man, I feel sorry for whoever's having to watch this. Okay, that's mostly out. Sorry, that's because that frame right there actually, it has shattered carbon fiber shards inside the arms. That's because this drone was actually put out of service by a crash due to vibrations. And yeah, that's obviously why I went with this tube hit right here. I moved away from the square tubes and moved to rounded tubes, which offer more structural stability for the same amount of material, purely just because of the circular walls. And yeah, this drone was more sort of a testing bed in terms of, as you can see, it's much more solidly built. That's carbon fiber infused 3D printed PET-G right there. More carbon fiber, more carbon fiber. What can I say? It's more of a testing bed because I wanted to test how I could get better efficiency out of my motors. As you can see, these motors mounts are actually, as you can see, also 3D printed. They're designed for motors to be mounted both on the top and the bottom, allowing for this drone to be reconfigurable in a coaxial configuration. Coaxial meaning a propeller on the top and the bottom. This is so I could experiment with different thrust setups, different angles. I could rotate the motors to do other tests. And yeah, right now there's a LiPo in there, but that's just for fun because I wanted this thing to discharge at a really high rate so it could fly really fast. But yeah, good drone. This thing, roughly the same amount of flight time as that drone over there. Now let's take another look around the shed. There have been several years since I worked on those first two drones. As you can see, I haven't been sort of waiting around. I've iterated on roughly 10 to 15 different models of drone. That's an interesting battery pack. That used to actually be on this drone, actually, if I remember correctly. I've spot welded that one together from high-density lithium-ion cells. In fact, these are the same spec as the ones you'd find on a Tesla Model 3 or Model S nowadays, although they are switching to newer cells. Through here, we have some more drones. All these are carbon fiber, different sizes of propeller, different sizes of frame, different sizes of tube. Flight controller stack remain roughly the same. Here's another one. Here's another one. Sorry, my camera work is not very good. But I've been iterating on these drones for a very, very long time. And I kept going. There's a nice little pillar drill. I'll get more onto why I use this one here in a bit, but... Oh, those jumper leads are a huge clue. Okay, well, we head into the house where my most recent efficiency drone lies. This is the one that you've probably read about in my little summary. Turn the lights off. And this is the one that is seeking to set the world endurance attempt for an RC drone of 3 hours. If you Google it, you'll probably see something ridiculous saying 17 hours. That's because it's not an electric drone. They've shoved a hydrogen generator on, which is cheating. The actual efficiency of this drone is as good as it gets, which is why I'm measuring it for an electric drone. Sorry, it's quite rainy here in England. Well, I'm guessing it's rainy wherever you're watching this from as well. So, did I just get locked out of my house? Somewhat. Okay, good enough. Well, that's amazing. Well, here it is. Let me take this to somewhere slightly more quiet. Let me sign into this. This is the sketchiest video ever, but you know what, it's fine. I'm gonna put this in my pocket as I carry this to the other room. Okay, this is gonna have to do. This is so informal, but you know what? That's okay. What sort of lighting am I in the mood for? There you go. Alright. Here is my most recent attempt at building an efficiency drone. This is the one that I'm trying to get certified with Guinness World Records to beat the world flight time record. Let's have a look at this. That's the flight computer stack right there. What's this? Okay. Statistics, tracking, stuff like that, whatever. Okay. This drone, this is everything I've thought of over the years to improve efficiency, all my research, but done to the highest degree, as in, like, I've taken everything to the most extreme level possible. Because that's what it takes to beat these world records. If you have a drone with 30 minutes of flight time, which is your typical drone, how are you supposed to get that to 3 hours? Well, the answer lies here. And hopefully these answers can be applied to drones all the way across society. So hopefully after this record is set, I can sort of publish more about how I've done this. Okay, where do we start? Carbon fiber tubes, as thin as possible, whatever, material loss. Let's talk about the motors and propellers. This is actually a pretty big factor. The average racing drone gets around 5 grams per watt of efficiency. These things are targeting 20. You might be asking, how is that possible? Well, firstly, let's look at the motors. These aren't the typical type of motors you find on the drone. These are pancake motors, which means they're flat. It means their electric fields generated are much more efficient because they're right next to these magnets. And that's just an improvement that most drones could really have. Propellers and motors need to be efficiently paired. In fact, I'd argue that the pairing of a propeller with a motor exponentially increases its efficiency. So if you miss that ideal value by just a slight amount, the potential loss in efficiency is exponential. And that's why these propellers were actually, I had to custom drill them to fit onto these motors and everything. This ESC is just the most efficient one I could find after much testing. It's due to the fact that it uses things like MOSFETs for switching power, stuff like that. It converts excess energy back into something that goes to the battery via eddy currents, as opposed to just something that, burns it. Also, configurable motor braking, PID tuning, stuff like that. All these little things that add up. I've gone as far as removing the housing from these flight controllers. I've used the most lightweight flight controller possible. I had to put together this flight computer stack myself. You see, it's a carbon fiber plate that's sitting on. GPS module being stripped of its housing because, weight. What's that? That's the receiver. Power module. This is only on here temporarily for me to be able to log my power draw, which is around 290 watts, which is great for something that weighs, 5.5 kilograms. But yeah, this is going to be taken off for the actual attempt. Right. Battery pack. This was put together myself, spot welded from extremely high density lithium ion 2170 cells, which have 5,800 mAh. I think these are the LG 50E cells, if I remember correctly. And yeah, this is pretty much it. It might not be as impressive as you were thinking, but at the same time, this is, a distant relative of the drones you'd see on the street today. Yeah. What else is there to do? You can hear the ESC's beep if you want. Yep. Right. This might be a little bit underwhelming for you, or overwhelming. I'm not sure what your standards are. But I'll leave this drone alone for now. This drone is in the flight testing and troubleshooting phase, so because this application is due the 1st of November, I do not have any proper clips of it flying right now. I need to get this application sent. But if you're interested, I'll put videos on this channel maybe. I don't know if they'll be up by the time you see this, but yeah, that's cool. In contact with Guinness to schedule a slot to get this booked. Let's talk about the real crown jewels. The giant drone, which you've probably been reading about, the one that's meant to have a payload of 120 kg. Let's just talk about that drone for a little bit before I even go and show you around. Building a drone that large is a serious challenge. The amount of battery you need on board, I settled on 20 kilowatt hours, which is ridiculous. The average house draws around, 0.8 kilowatts? I don't know what that is in America. Well, for us, it's around 800 watts, which is pretty good. A fully loaded electric car, let's say the Tesla Model S, has around 80 kilowatt hours of batteries on board. Model 3, around 75. And 20 kilowatt hours is just an absurd amount to have in the sky, considering how much those cars weigh. How do I put this into perspective? Your phone, being a large phone, probably has around 15 watt hours of battery. We're talking about 20,000 watt hours. Why do I have that much battery on a drone? Well, I took the same principles from this drone and around the other 20 that I've worked on in my shed over the last few years and decided to scale them up. Why? I wanted to prove that viable flight times are possible for large electric craft, as opposed to using hydrogen, which isn't really very successful because large hydrogen reactors cannot generate enough power to lift a drone. Or fuel, which come on man, just using a helicopter at that point, or a plane. So, yes, what was I talking about? 20 kilowatt hours of batteries. Okay, as a student, where do I source that? I have some funds from when I worked freelance, doing crypto work on contract. We don't talk about that. But ultimately, I don't have the money to buy 20 kilowatt hours of brand new cells. So I started looking for ways to find huge amounts of lithium ion cells for cheap, and I eventually settled on a wrecked Tesla. Yep, you heard that right. So I saw a Tesla that had been wrecked and someone was parting out, and I decided to hit them up. And I was like, hey, mind if I take a look at the batteries? And I ended up buying the batteries from this wrecked Tesla, it's that like a write-off from a crash. And I reverse engineered them and figured out how to repurpose them for my purposes, which in fact did work. It did take a lot of, reverse engineering, literally. I had to figure out how the current collectors worked, how Tesla had assembled the cells, how to take off their BMS and replace it with my own. But that's something I managed to eventually do, dropping my costs from around £10,000 for new cells to whatever I paid the guy, which was £2,000. I also have some packs left over, which I plan on using as a home energy storage system. But, yep, that's unrelated. Carbon fiber tubes, the normal. Motors and propellers. This was a hard one. But in fact, it wasn't that hard for me. In China, agricultural drones are a normal thing, with a wingspan roughly equivalent to this drone here, except they're not going for efficiency, they're going for raw power. So I bought a bunch of, basically I bought a bunch of damaged parts from crashed drones and reconstructed the motors using brand new bearings and propellers. This was a really cost-effective way for me to get functional motors. Without further ado, let's go look at the chassis of the drone in the other room. It's currently partially disassembled because I'm making some modifications to the frame. But yeah, let's see what you think. Here we are in the kitchen. You might be thinking, why is this in my kitchen? I'm gonna be honest, it should not be in my kitchen. It was outside. We bought a gazebo just to carry this. Can I put this on ultra wide? Kind of. But yeah, here it is in all its glory. From propeller to propeller, this thing measures 5.6 meters by, what was it, what's 2.2 plus 1.2? 3.6 meters, which is crazy. This is one propeller. This is my arm, okay? Pretty self-explanatory. Assembled like the previous drones, except on this scale, I had to make these joints out of aluminium. These tubes were just bought in bulk from, like a metal shop. I went to, found one that would work on the tube. I worked on a couple other designs. I was thinking about 3D printing or even making carbon fiber joints, but I just needed the strength from this. So bought the tubes, took them, that pillar drill you saw in the shed at the start, that was used to sort of mill out inserts so they fit into each other. I constructed molds, took these to a welder, and gave him the schematics, and boom, he welded them, did charge me, but hey, that's how it works. Those assembled, put them on here. My method of fixing them to the tube was to put them on the tube and drill a bolt through, use compression to friction fit all the tubes together, and it's a pretty solid chassis. I can pick this up from one corner myself. Okay, ESC, electronic speed controller. These things are a bit pricey, but whatever. Okay, the power cables. So, you have a plus and a minus. Copper is expensive nowadays, so in fact, to get these, I bought a bunch of jumper leads off Amazon, cut off the ends, and just used them as my power cables, which worked perfectly and saved me from capitalism, who were trying to charge me 100% markup. There is one battery cell that I've removed from a Tesla. Let's take a look at that. Okay, well, here we have positive buzz bar, which is strapped into these Tesla current collectors. These, you can see the pack was separated. This was done using a drill and a saw after draining these cells to 0 volts, so they became inert. Power switch, yeah, row of cells. So let's just turn that on. Yep, those beeps mean there's power. I'm not sure if you can hear it over the music being played. But yeah, so this drone's currently being reconfigured. There's a second pack that's meant to be in there. I was just testing with one for now. Yeah. Here's the remnants of the Tesla packs, which those other packs were taken out of. As you can see, that it was slightly destructive, the process of separating them, but it was entirely planned out. What are these? More pancake motors. Oh, and some Vex Robotics kit. You'll see more about that in, another photo or video or description? Who knows? I apologize for the informality of this makeup portfolio submission. I hope you enjoyed it, and I hope that all the nuisances in the background weren't too much. I'll try videos of this boy on the YouTube channel as well, so please check that out.